Let's talk about some analysis I've done recently on the impact the sun has on the Earth regarding earthquakes. So we'll keep this super simple. This is some analysis of data. This data is solar. I'll put it right up here, solar flux. Okay, if I know what solar flux is, well, you can look it up. Solar flux from March 1st, we'll just put 3/1 to today as I do this video. That's 5/25. This is 2024. 2024. So March 1st through May 25th. So not a huge amount of data, but enough data for us to do some analysis. Let's take a look at this. This solar flux, this is the solar flux scale over here, obviously. Okay. So zero's down here. High infinity's up there. Dates go this way. All right, dates go this way. You can see the dates on the bottom. All right, so let's talk about this. March 3rd. Now, these are not scripture books and chapter, though they kind of look like that. This March 3rd, there was an earthquake 6.8, and it was right around, hello, phone, right around like 140 in regards to flux scale here, okay? Flux measurement. But you can see, just if you're looking at this from a geometrical perspective, that the flux was declining, right? In a declining phase. And we had a 6.8 earthquake, big earthquake. Then right here at the bottom, as it's bottoming out right around March 10th, this was March 14th, we had a 6.2. Look at this, no earthquakes all the way up. Then on March 22nd and the 23rd, we get two big earthquakes, a 6.4, and the day later a 6.9. Then on the way down, right around 180, March 26th, we had 6.4, then no earthquakes. No, when I say no, I mean no significant earthquakes. Like, I'm only measuring earthquakes that are greater than 6.0. So if it's a 6.0, I'm not taking into account. So maybe I should put that up here. Greater than 6.0, which I'm categorizing this as significant earthquakes, okay? So no earthquakes that meet this criteria. Between here and here, all the way down. We get to April 2nd, get a huge earthquake, 7.4. Look how low the flux is. Way down here below 120. Way down here. 3 days later, a 6.8. And it's maybe like 125, maybe 127, somewhere in that area. Then just 4 days later, a 6.4. So get all these earthquakes, big earthquakes, all clustered together. Down here, below 130 flux. That's important to remember that. That number matters. There's an approximation below 130, which would be like right here. Okay, goes up, 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 up. We don't get any earthquakes until right here. What do you know? Right around 180 again. We get a 6.5 on April 14th. No significant earthquakes all the way to the peak. April 22nd, we get a 6.1. Then all the way down, 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 down. We don't get one at 180 this time. We get one all the way down. We get near the valley down in this area. We get a 6.5 on April 27th. Okay. It turns, it comes up, and what do you know? Right around 180, maybe a little higher, we get a 6.1. Wow, that's three of them. Look at that. 1, 2, 3, all in this line. Look at these zones. That we'll call this the bottom zone. Okay, kind of includes these guys. We'll just call that zone 1. I'll put a big old fat 1 in there. Ugly looking 1. Try to make that better. Let's call this zone 1. Okay, this is zone 1. When it's below 130, we get these earthquakes down in this area. So maybe this one was a little higher, got into 140. This one over here is like 150, so it's not always below 130. Then we get the 180 band. Get this band like right in here. Earthquakes right in there. 1, 2, 3. Then we get earthquakes that happen at the peaks. They happen up at peaks. Not necessarily flux related. It's just peak related. So it's really clear, right? There's some resonance kind of going on here. Okay, going back over to the here. We come up, we talked about the 180 area, May 5th, 6.1. We get all the way up here at May 8th, right at the peak, another 6.1. But bam. I mean, right at the peak. No significant earthquakes. As a matter of fact, this whole time up here was when we had the massive solar storms in 2024, which will be remembered for decades. One of the greatest massive solar storm 2-week period in the history of recorded history happened here. Everybody remembers the Northern Lights and all this stuff. This is all this big mess up here is. Which, by the way, the experts said this was going to be a weak solar cycle. Wrong. They totally missed it. Now they did a 180 and said, wow, strong solar cycle, one of the greatest ever. We had some of the greatest solar flares ever in this period up in here. Some of the biggest solar flares that ever occurred in recorded history have happened here. Just in this past few weeks. Now the experts suddenly change their mind and go to 180 degrees the other way. Gosh, they can never admit when they're wrong, you know. The experts. My backside. These people, experts. Get out of here. You know what geologists are going to say if they ever watch this video? That doesn't prove anything. I'll continue to bury my head in the sand. The sun does not cause earthquake. I'll repeat it 10 times myself. The sun does not cause earthquakes. The sun does not. Yes, it does. And if you jacksticks, seismologists want to bury your head in the sand, go ahead. I don't care. The data says otherwise. Deal with it. May 25th, 6.3 down here, getting below 160. I think we'll probably see, if this continues to decrease, which there's no guarantee it will, but if it continues to decrease, especially if it starts getting below 140, gets down in this area, well, guess what? We just might see some big earthquakes come in here. If it stops and bounces before then, okay, that changes the picture. I put out an earthquake warning about 2 or 3 weeks ago, and I was expecting some big earthquakes. It didn't happen because we had this big, massive, sustained solar flux, which was evident by all those solar flares for quite a while. And what did it do? It delayed the earthquakes. That's right, you heard me say it. When you have sustained solar flux like this coming in from the plasma coming in from the sun, the earth is charged. Okay? It might be negatively charged, it doesn't matter, but it's charged. Okay? And it delays earthquakes. That's why the earthquakes didn't happen as I was forecasting them to happen. But guess what? Now we're seeing one here on May 23rd. Pretty big earthquake, 6.3 just happened today. And like I said, if this continues to decline, if we start getting below 140, start getting down in this area, we might see some really big earthquakes. We might see some high sixes, might even see a 7. Okay, so be prepared for that. But this is not about... yes, this could go. This is a breakthrough. First of all, okay, I am now thoroughly convinced that the sun, under certain conditions and plasma flow from the sun, and we're measuring it through flux. Okay, absolutely, we can predict earthquakes. Where? That I don't know. Can we predict the likelihood of earthquakes? Yes, we can, and this proves it. And I think I've only, like I said, only collected about not quite 2 months worth of data here, maybe like 6 weeks worth of data. But I'm pretty sure if you stretch this out, you're going to begin to see some correlation here that like repeats itself over and over and over. Now, it may not always be exactly consistent because there's probably other factors. Okay. So I think this will go a long way in predicting the likelihood of earthquakes. All right. For those that care to really take the time to pay attention to the data. The seismologists, because they're more concerned about their funding, they'll probably ignore this for a long time because they want to be the experts when they're not. And that, I think that aspect of it, you know, the earthquake prediction through probability, that's fine. I mean, I embrace that. That's great. I think this budding and this budding science, I guess you can call it, that's just starting to, just like it's in the infancy stage, it's just starting to get going. And I'm happy to be a part of it because I can tell it's happening. I mean, I see it, the data doesn't lie. I think that's in the years to come, we're going to begin to be able to predict earthquakes at least a lot better than we are now, which you can't predict earthquakes right now. They're absolutely horrible at predicting earthquakes. They totally suck at it, even though they call themselves experts. But that's probably going to begin to change slowly, okay? Especially when the old guard kind of just like gets out of the way and their greed gets out of the way, which is what drives most of their analysis, is their next year's funding. Once we get rid of that old guard, get rid of the old crowd, and get rid of this paradigm we're in of funding is more important than truth, because don't make no mistake, that's where we're at. The world is on its head. Funding and money is more important than truth. But that'll probably change. It's going to take some time, but that'll probably change. Eventually, truth will prevail. It may be slow coming, but that's probably what's going to happen. So once the old guard gets out of the way, we can move forward, really move forward with science, where truth prevails instead of just funding. Then I think there's a bright future. So I think this is part of that. Okay, and that is an important aspect of this. But let me take this a step further. What I'm really after here is this proves that the universe is electric. And a lot of people don't even understand what that is. They're just going to get caught up in this video on, oh, great, we can predict earthquakes by looking at sun data. No. I mean, yes, that's important, but you're missing the really big picture. And that is, this proves that the universe truly is electric. And it's driven by an electrical process. And plasma carries electrical charge, right? It carries the ions, if you will. And that's happening not just across our solar system, from the sun to the planets and from the planets back to the earth. Because, yeah, it's a two-way stream, by the way. But it's happening outside of our solar system. It happens on the galactic level in the Milky Way galaxy. It happens across galaxies, and it happens all across the universe. Okay. And even though I'm not going to claim to have it all figured out, what I think is probably happening here is like a double electromagnetic torus. Okay, if you don't know what a torus is, it's kind of like a donut. Now I can't draw with a darn, but a torus, kind of like a circle. Okay, it has this is two-dimensional, so it's really hard to draw. Like I said, I stink at drawing, but I don't know. It's kind of like another, I guess, thingy like this, and you've got lines that kind of curve, and I don't know. I can't draw a freaking torus with a dam. It's kind of like this. Okay, you can go look up torus. Go look up electromagnetic torus. Okay. But what's probably happening is a double torus is probably one of the most basic structures in science. So there were another torus, kind of like here, my cruddy drawing, same thing. And just whatever, another donut here. You have to imagine this is curved, right? These edges are curved and have a rounding. Okay, and this is the top and this is the bottom, and I know it's horrible. But what's happening is probably electrical current flows in this way. Okay, it flows in like that. Plasma flows kind of like this, probably something like this. And it makes it on the upper part of this double torus. It goes up, comes down the middle, and back out. And this probably does something like that, back out. Yeah, and it looks like somebody's butt, whatever. And then this one does the same thing. It comes down, goes right up the middle. Okay, excuse that, it's pretty crappy. Back around. And then this one does the same thing. It migrates down, comes back up the middle. Okay. So it's probably something like this, like some type of double torus where electrical current's flowing in, it flows up and around. Okay, and so guess what? That's probably how the Milky Way, the center of the Milky Way works, more or less. There's no black hole there. It's a black hole. It's just a big black hole. I mean, that's science fiction gobbledygook. It's just total garbage. Guys, we don't know what to call it. I know, an infinite black hole. Science fiction mumbo jumbo, No, it's not a black hole. It's just electromagnetic field. This is probably like the nexus to the electromagnetic field, something like this. Okay? It's not a black hole where things just disappear forever. Oh my gosh, another dimension, People get all spooky and weird, right? Freaking physicists. So that's probably like the most fundamental structure to nature. It's like some type of electromagnetic torus or double torus. And that's what's driving all of this. And another newsflash, light is not the fastest thing in the cosmos. Not even close. Because galaxies are communicating with one another across great distances, and they're doing it instantaneously. I can almost guarantee it. Can I prove it today? No, I cannot. Do I believe they're communicating with one another? Yeah, I believe they are. Do I think they're sentient beings, galaxies? Okay, maybe not, but do I think there's some type of form of communication between galaxies? Yep. It's electric in nature. And I think the communication across galaxies is instantaneous. It's not, you gotta wait for light to travel all the way over there. Do I think light plays its part under some circumstances? Yeah. Do I think there's something faster than light that communicates to galaxies? You bet. And the universe is definitely electric. And this analysis is just the beginning to proving that the universe is electric. Okay, I think there's a lot more to come. I don't claim to be, I'm not astrophysics. I'm not, I don't have this type of degree in astrophysics, astrophysiology, okay, whatever you call it. But I don't have to. I don't have to be the guy that went to college and got 18 years and everybody discounts your analysis because, oh, well, he's not a PhD. He's not a PhD. Oh, I'm actually discrediting him. And there's the issue with the PhD crowd. I'm not knocking those PhDs. We need those people. And I'm glad there's PhDs. We absolutely need their expertise. But it's the arrogance that goes along with it that we don't need. And the assumption that only they know best is total hogwash. I'm smart enough to do analysis, and analysis tells me there's definitely something here. All right, so great video, guys. Hope you all really enjoyed it. I don't really care if you subscribe to my YouTube channel or not. This is not about clickbait. I'm serious. I don't care. You want to join? Join. I don't care. I think there's going to be some major breakthroughs as we move forward. And like I said before, once we get the old guard out of the way, and we replace I'm more concerned about my funding than truth crowd, and we get back to seeking truth, and funding is no longer king of the hill, then we're going to make some serious progress. But that may take a little while. I think there's an amazing breakthrough. I think we're going to see more of this. I think we're going to see other people who are going to dive into this. People far more talented and skilled than me are going to begin to dive into these kind of numbers and dive into the data, and they're going to figure this stuff out a lot better than I am. But I'm more than happy to get the ball rolling. Guys and gals, guess what? We live in an electric universe, and there's no getting away from it. And it's amazing, as they rolled out the James Webb telescope, how it's proved a lot of the theories about electric universe. And no, I'm not just saying that to jump on the bandwagon of electric universe, but I've looked at it carefully, and I'll tell you what, it has a lot more going for it than Big Bang nonsense. That's it for now. Hope you enjoyed it. Hope everyone's having a great weekend. Memorial Day. I think it's Memorial Day weekend. Enjoy your 3-day weekend for some people. Talk to you all real soon again next time.